Hello. All right. I think I was muted on the mic. So let's get started. So today I'm glad to hear to share Polyhedra most recent progress on our zkBridge and on our integration with BNB Zero2Hero Hackathon. We'll start by talking about brief introduction on what Polyhedra is and what we are building with zkBridge. And then we'll go through a demo on our developers, how developers are able to integrate their own application with Polyhedra network with our most recent zkBridge interface. So let's get started. So what is Polyhedra? Polyhedra is building the infrastructure for Web3 interoperability with zero-knowledge proofs. So regarding the Polyhedra network, we focus on interoperability solution for the entire Web3. In our vision, we should be able to connect everything in Web3, no matter it is layer 1 or layer 2. And we also should be able to connect Web 2 to Web 3. How we are able to do that is through the zkBridge that we are presenting today and that we are bringing to the BNB Zero2Hero Hackathon. So we offer the zk interoperability through zkBridge through our innovative zkP protocols. What we are bringing, including Orion, Virgo, Gemini, and Marlin, we bring the most advanced zero-knowledge proof protocols to the space, which has tremendous advantage compared to existing zkP protocols. And we also encapsulate all those zk protocols into easy to use and easy to call API and SDKs for our developers to easily deploy their application on any of the blockchains we support. So before building on zkBridge, we can take a look at what's the principle of zkBridge. Actually, the principle behind it is quite simple. What we are doing is that we are taking the block on the sender chain, and then we verify the block through the zkP protocols. Then we relay that block to the sender chain. And on the sender chain, we have our updater contract, which automatically verifies the proof that gets relayed from the sender chain. And then we can do the following steps after the proof is verified, which means after the block is synchronized. For our developers, well, the underlying zkP and the circuit is quite complicated to understand. But we are able to encapsulate everything into nice and simple API calls. Indeed, we have only 2 API calls that you need to take care of when you are deploying your products, your apps on the zkBridge. So for developers, what you need to understand is that you will have your application contract on the sender chain, which is anything you'd like to do. You can do GameFi, you can do DeFi, you can simply send a message, or you can relay an NFT, which we will talk later in our code demo procedure. And after deploy your contract on the sender chain, then you're able to call our zkBridge APIs. Then our zkBridge will automatically help you to relay your transactions from the sender chain to the receiver chain using the block header relay network. And then you will get your results on the receiver chain, basically saying, yes, your transaction has been relayed and it has been verified using the zkP protocol. And after that, you can go on with any of the logic you would like to deploy on receiver chain. Basically, what we are offering is simply a relayer service relays the message or anything, relays your transaction from your sender chain to your receiver chain. And now we just come up with the zkBridge mainnet alpha version, which was released 2 weeks ago, that supports 10 different blockchains, including Binance Smart Chain, BNB Smart Chain, Ethereum, Arbitrum, Avalanche, Optimism, Polygon, and Phantom, Metis, Genesis, and Moonbeam. And in the future, where it will be able to deploy more and more blockchains into the system, or currently you can play with the 10 existing blockchains that we support. We do support both mainnet version and the testnet version, which you are able to see on zkBridge.com. So besides the zkBridge that relays information from one chain to another, in Polyhedra's vision, we do believe that everything should be interconnected. What we mean everything is that it's not limited to Web3 only. You are even encouraged, and we do encourage you to try out Web2 applications. So the Relayer network, the principle behind is that we collect a piece of information. It could be block header, and it could also be Web2 database. We collect that piece of information, then we generate a proof, proving the validity of the information. After that proof is generated, we put that on chain onto a layer 1 or layer 2 blockchain, which can be verified by our updater contract, which is a smart contract. In that way, we're able to connect layer 1, layer 2, or Web2 data to any layer 1 or layer 2 blockchains. No matter it is EVM or non-EVM, no matter which ecosystem it belongs to, no matter which chain it resides in, no matter it's Web2 or Web3, we can connect them all. And we encourage you to explore more possibilities with us through the zkBridge protocol. So why we are able to do that and what attracts you to build our zkBridge is that we offer our core algorithm, which is a very advanced and very fast algorithm. How we are able to do that? We call it Virgo. I'm gonna skip over the technical details, but I do want to stress on one point with the Virgo, why it is fast and why we call it the fastest zk protocol ever, is that maybe some of you may know that we need to write circuits for zk protocols for the proofs, for proof generation. However, currently the circuits, no matter it is Graph 16 or Plonk, the circuits cannot be computed parallelly, which means that no matter how many cores you have, how many machines you have to put one circuit generation into one machine, which may take several minutes to maybe 20, 30 minutes for larger circuits. However, we come up with the Virgo, which is a distributed proof generation system. By distributed, we mean that you are able to put the proof generation process into or even 3.5 seconds for so hopefully it's better now. Have that weather. Sorry, I had a glitch on the internet. We'll resume soon when I get the slides back. One sec. Okay, cool. Thank you. Sorry for the glitch, bad internet connection here. Resume on what we were about to talk. So with the Virgo, with parallel computing on the proof generation, you are able to generate a proof within several seconds, which supports you to build highly interactive applications. Imagine if you need to wait for 10, 20 minutes for a proof to be generated and verified, that's going to be almost impossible for you to build an interactive application because you need your user to wait for the proof to get responded. But with parallel computing, we're able to extremely raise the limits of the ZKP generation process. Within 2, 3, several seconds, we can build much better, much more user-friendly applications, which you will be able to see. You have already seen on zkBridge.com. The entire cross-chain process takes you, a minute or two for you to transfer an asset from your sender chain to the receiver chain. And that's due to our parallel computing technology. So this is some statistics showing how fast we can be. The Virgo is what we are using, the Polyhedra is building on. Compared to the classic algorithms, we are faster to like 1 or 2 magnitudes compared to the older ones. So summarizing why you want to build on the zkBridge. So trustless and secure, that's the first thing that comes out. The one reason why we're proposing zkBridge compared to the classic bridges, the MPC bridges, is that in the original design, the MPC bridges, you need to trust third parties, you need to trust the nodes that you're relying on. However, imagine a case that if you are transferring $1 billion through the bridge, the nodes are highly incentivized to steal your money, and you are trusting them. So here comes the trust issue. And Polyhedra network, we don't want to trust anyone. So in internal, we have a saying that in math, we trust. The only thing we trust is mathematics. 1 + 1 will be equal to 2. And if we trust that and we build on that trust, we call it a trustless bridge because there's no human error involved. And that's maximum security we can achieve. So besides trustless, we talked about how we're able to improve the proof generation procedure, the speed, by parallel computing, which we call it efficiency. So efficiency is quite important in today's world, especially for developers who want to build cross-chain applications that are highly interactive. You want your users to have smooth user experience by using the zkP protocol. The parallel computing enables that. We can build efficient programs for our users to experience. Decentralization. Decentralization is always the talk, always the theme in Web3 world. And how we're doing that is that the parallel computing, we can distribute proof generation into different machines, and those machines can be held by different parties. Well, while in the network, as long as there is only one trusted party that's making the honest proof, the entire system will be able to pass. Yet, the decentralized proof generation helps us to reduce the risk of like certain nodes that are down. We still have other spare nodes for us to generate the proofs. And that's how we achieve decentralization. Regarding extensible, we do have the we do have the block relay network that can relay any block headers. For us, there is no difference between EVM chains and non-EVM chains. As long as it is a blockchain and it has its own consensus, we're able to prove that and relay the block. So basically, you can build your application on any of the blockchains you would like to, and that's what we call extensible. We have no limitations on that, and your application can even connect to Web2 services, as we talked about. Lastly, universal, following on the discussion, zk protocol, it doesn't have to be generated on chain. The proof generation process is usually done off chain. So which removes the limitation of using the blockchain only. We are talking about next billion user these days, that we are thinking of how we are attracting the next billion user. However, we all know that on the earth, we have only 8 billion people, and we are not able to just come up with 1 billion more people out of nowhere. So the key of the next billion user is conversion. We need to convert the Web2 user to Web3. We need to bring the Web2 users to Web3. How we do that? We need universal applications that both Web2 users and Web3 users can experience. And the technology behind that, the connecting Web2 to Web3, zkBridge is one of the things, because for zkBridge, it doesn't have to be on blockchain. The proof generation, the proofs can prove in Web2 data. Proof generation can be off-chain, while we bring all those data into the Web3 world. And that's what we call universal. So some of the example use cases that we will soon see in later part of the talk, including cross-chain data availability, where we can transfer any data. You can transfer your NFT, you can transfer your asset, you can transfer your message, anything. You can move that from one chain to another. Then we have the, we encourage you to build cross-chain DeFi protocols, as we talked about. zkBridge is trustless, secure, and efficient, which allows you to build cross-chain DeFi protocols with smooth user experience. Your users are able to experience the zkBridge, experience the cross-chain transaction with a finality of like 1 minute or 2, and that should be smoother than most of the cross-chain applications right now. And we also encourage you to build multi-chain NFT and GameFi projects, because we do support NFT cross-chain and message cross-chain. You can utilize our NFT cross-chain protocol to transfer NFTs, no matter if you want to build a multi-chain NFT marketplace, or you want to build a multi-chain games based on NFTs or multi-chain GameFi. You can all utilize our zkBridge protocols that we offer right now. So with all those being said, those are the principles, and those are why you may want to try out the zkBridge. And the good news is that the zkBridge protocol is already live on mainnets. And it is on zkBridge.com, which you are able to see on the right bottom corner of the slides. So we do have 2 products that are ready to use and you are ready to build on. And those are also the samples built for your developers to get an understanding of how we build applications on zkBridge. One is zkBridge for NFTs, which allows you to transfer NFTs from one chain to another. And the other is a zkBridge for Messenger, which allows you to send any arbitrary message from one chain to another. So welcome to experience those 2 pre-made products using our zkBridge APIs. Since here today for our bounty on Polyhedra network, this is the overview of the bounty. We do offer a bounty of $5,000 in total, with a gold prize and 2 silver prize. The gold prize comes with 3,000, and the silver prize 2 silver prizes come with 1,000. And the bounty would be build applications on zkBridge for asset and data interoperability. It is a quite general topic. We do encourage you to open up your mind, to use your creativity, to try out what we can do with zkBridge. Since it is a rather new technology, and I think we are probably the first bridges that are using zk, I would like to encourage all our community developers to think of the possibility using zkBridge, as we provide trustless, secure, and highly efficient cross-chain system. And those are all built on zk protocols. And the good news, again, is that you don't need to understand ZK protocols to start building on. The only thing you need to understand is Solidity, smart contracts, which I imagine most of you already are familiar with enough. So some of the ideas that may give you a hint on where to start and some potentially interesting projects you may want to take a look at, including cross-chain liquidity protocols and multi-chain DeFi projects. We do encourage you to build some DeFi applications using the zkBridge protocol, as using ZK, it is secure enough. You don't need to worry about your fund will be hacked through the bridging process. Then with zkBridge, it is highly efficient. You can finish your cross-chain transaction with the proof can be finished within several seconds. And the total finality, including the API contract, including the block confirmation, and everything, could be a minute or two. Besides that, we can also think of multi-chain games, Web3 games, and GameFi projects, which a lot of games may use the messages you need to transfer data from one chain to another, or maybe you already have a game that is running on one chain and you want to transfer that game entirely from one chain to another. Say you have Ethereum and you want to transfer your entire game onto BNB chain. Yes, we help you do that, and we do have all the APIs and SDKs ready for you to just move all your data, everything, or data or assets from one chain to another. You can try out multi-chain NFT marketplaces and NFT-fi protocols. As one of our sample products that we are offering on zkBridge.com is that we have a NFT cross-chain bridge, which you can just directly use. You can use that for a NFT marketplaces, for multi-chain NFT marketplaces, and you may want to use that for NFT-fi, for a multi-chain NFT-fi, because we help you to move your NFTs smoothly from one chain to another, which you can experience on zkBridge.com. Besides that, some other applications may include multi-chain DID protocols, which you can utilize our cross-chain message passing protocol, which you can send your user credential from one chain to another, and which you can also just generate the proof of the user credential onto the blockchain and just pass that proof from one chain to another. And we also would like to encourage you to think of multi-chain DAOs and how that would be potentially combined with zkBridge. Maybe we can transfer the DAO voting tokens or just voting power through the form of simple data. Then maybe DAO credential using NFTs on different blockchains. Basically, whenever you want to move something, anything, message, data, or just a piece of information, or even code from one chain to another, you can think of potential ideas to combine that with zkBridge we're offering. So thanks to the community. And if you have any questions, you can send your inquiry to support at zkBridge.com, which you will able to see at the bottom of the zkBridge.com page. And I do also encourage you to explore the zkBridge.com to try out the Messenger and the NFT cross-chain services. And this is not the end of the talk. This is just the end of the presentation. And now I'd like to show our developers, our hardcore developers, how the code works and how you can actually call the zkBridge APIs. But before that, please allow me to re-upload my video here. Since I just got disconnected, I do need to re-upload the resources again. One sec, I think that takes, or should be less than a minute. Cool. We do have a video here. Hopefully I do have control over it. Yes, cool. So this is the demo video of how you can use the zkBridge API, what we call the iZkBridge receiver and iZkBridge sender. So basically, what you need to do, as you can see in the demo, is that we need to deploy two smart contracts. So one on the sender chain and one on the receiver chain, which is your application contracts. You can write anything into the contracts. You can write all your own business logic, no matter you want to do DeFi, GameFi, or NFTFi or anything. Just write your smart contracts as normal. However, we do require you to build one thing into the smart contract, which is, and you will be able to see here, which is the iZkBridge receiver interface. You need to put that piece of code into your smart contract here, which you can see, including the zkReceive. You do need to call the zkReceive method, which will ask you to provide the source chain ID, your sender chain ID, source address, your sender chain address. Then you need the payload. The payload, which is your the piece of information that you want to send from one chain to another. So here we'll be able to see how that works out. So that's on the receiver chain, and on the sender chain, you need to deploy another contract that is mirroring to your contract on the receiver chain, which let me scroll right here, which implements the iZkBridge entry point, and you need to put your corresponding information, including your receiver address, including your receiver chain ID, into that configuration, so that the sender chain know that which receiver chain that I am sending to. After those two smart contracts are being deployed, those two smart contracts are, remember, those two are arbitrary contracts. You're with your own business logic, just implementing the iZkBridge receiver and iZkBridge entry point API. After that, you need to deploy the smart contract. When deploying, you need to pass in your contract address for your contract on the receiver chain into your sender chain contract, so that the sender chain contract would be able to know which destination address I'm sending to. And after that is configured, every message you are sending through the sender chain contract will be automatically relayed to your receiver chain contract, to that specific contract that you just entered into the sender contract when you deploy your smart contract onto the blockchain. So here, this is a demo from Ethereum Goerli testnet to BNB Smart Chain testnet. So we do open up those for you for testing purposes. We also have the mainnet support for those two networks, but as we know, you do have cost to trying out mainnet. So we do encourage you to first deploy your contracts on testnet before you officially to build your business, build your logic on the mainnet. So here we are trying to send a message using the sender contract. On the left, you are able to see what we need to input into the sender contract. It's quite simple. You need to input the zkBridge contract, which we will offer you through our API. You just need to copy paste the contract that we deploy on the sender chain contract address. Then you need to put in your destination chain ID, which is the receiver chain that you are sending to. Then you need to configure the mailbox. The mailbox is the receiver address that you are sending to. After that, you can trigger the transaction. And because we are running on the local environment, please do remember to switch your network before you trigger the transaction. then you can pay for the transaction fee here. Then the transaction now is sent through the Ethereum Goerli testnet. Just wait for a few seconds for it to be finalized. Okay, cool. And now it is finalized. We do get the return result. So the smart contract is deployed already. Now we'll try to send a message. Well, here we use hello world, the classic message. Then we shall wait for a few seconds for that to be reflected on the blockchain to be that. Okay, cool. Now we have that returned. So I'll pause here. You will, after triggering that, you will see a transaction hash, your transaction hash on the center chain containing this hello world piece of message. So with that transaction hash, we do offer, which will be automatically done, but for demo purposes, we'll show how that works. So we do have a API for you that will be actually called automatically when you really build that on zkBridge. So you input your transaction hash on the center chain, and we will return you with the block hash, which is the block that this transaction resides in, and also a proof block, which is the MPT proof for this specific transaction. What you need to do is that will be automatically imported back into your contract, including the block hash, the block that this transaction resides in, and the proof of this specific transaction. And after that, this step, we are verifying the transaction on the receiver chain, as long as you have the source transaction ID, which automatically will help you to convert that into the block hash that the transaction resides in, and also the transaction proof. And the block and the transaction will be proved, will be verified through the smart contract that we already deployed on the receiver chain. Well, as here is in the local testing, so we'll manually switch the network to the receiver chain. After that is done, we shall get the return result on the receiver chain. I will wait for a second. So we do need to trigger the transaction. Here, pay for the gas. And then that's should be done. Okay, cool. And at the end of that, what you get return is a transaction hash. So this transaction hash is on the receiver chain already, and this transaction hash contains everything you need you configured. For demo purposes only, here we print the logs, and we should be able to see the hello world message here that we transferred on the sender chain to the receiver chain. And that's a short demo of how you can call the zkBridge API. So it's only two API calls, one on the sender chain and one on the receiver chain. On the sender chain, you can configure your own logic, anything you would like to send. On the receiver chain, you just automatically get that message with a transaction hash that is being returned to you from our API. Okay, at the end, I will take the questions. If there is any questions, I think you can ask. I do get some already, I think. One sec, let me check. So I do have a question here asking, can zkBridge bring atomic level interoperability between Ethereum and a shared sequencer such as Celestia? So the simple answer is yes, of course. As we talked about, zkBridge, it's a fully interoperable system that allows you to bring any message, any data from one place to another. So we do support atomic level interoperability between any layer 1 and layer 2 blockchain networks. So how we're doing that is that by employing a modular architecture, zkBridge actually empowers developers and users with a broad range of applications and features, including token bridging and swapping, including message passing, as well as computational logic that works with state changes from multiple blockchain networks. So for the applications you want to build, you don't need to worry about if it is EVM or non-EVM, it is on layer 1 or layer 2. We do support full interoperability between those systems, and that can be done with our zkBridge APIs that we offer. Can zkBridge? Okay, yeah, that's the question we just answered. Do we have? I wait for more questions to pop out. I think I do have around 7 more minutes for today's event. Yes, we do. We do have docs already. Actually, it is in docs.zkbridge.com, which let me see if I'm able to post that. Yes, so I'll try to type that in the chat. You can see all those information on zkbridge.com, including the thing we just talked about, including the NFT transferring, a complete NFT transferring demo product, then a complete message parsing. Then on the docs section on zkbridge.com, you are able to see the sample codes and also a explanation of the underlying principles and how you are able to call the zkBridge APIs. Docs.zkbridge. Yeah, that's for the documents that you may go to. And regarding a GitHub repo, we'll open that soon because we do have the code demos already, the one I just demonstrated to you, and we'll open that to our developer community soon. And also, I do like to put in our support email. We do have support at zkbridge.com, which if you have any questions regarding developing and deploying on zkBridge, you can always shoot an email to support@zkbridge.com, and we will reply to all those inquiries. So yeah, currently you can follow the instructions in the doc to build your applications on zkBridge. And I think because we only have 2 APIs, it's quite simple to use. If you do have any confusions, please let us know. I'll wait for more to pop out. Compare zkBridge with layer 0. Well, I think it is two. So it's 2 different things. We are fully compatible with layer 0. So what we are offering right now, the core technology. Okay, we'll switch the slide here. The thing we are offering is a relay network that's relaying one thing to another. So here we relay the block header. So we offer the core technology relaying the block header or any transaction that happens in the block header. So we are fully compatible with layer 0 using our zkBridge as a relayer and as an oracle for the layer 0 system. And we'll soon announce developer tools for our layer 0 developers, which you will feel quite familiar with. And we do love those who have tried on layer 0 to try on zkBridge as well. Okay, I'll wait for more questions if there is any. While I'm gonna type in some of the links that you may want to try out on our zkBridge. So regarding the things we just talked about, we do have a messenger demo already, which you are able to see under zkbridge.com/messenger. We do have the NFT transferring ready, which you should be able to see under zkbridge.com/NFT. And for our developers, we do have our Gitbook open already. Oh, actually, I found out we do have sample codes on our website, the APIs and how you can call the APIs, the two interfaces. And I'll post that. So for developers, please look at zkbridge.com/developers, which you should be able to find all the tools and all the information you need. So I think we are approaching the end of the talk. I think it's 45 minutes. So, okay. At last, thank you everyone to come for listening today. And we would like to encourage you to think creatively, think innovatively to see how zkBridge can empower the cross-chain future, to empower a multi-chain future. And if you have any questions, again, let us know. Send an email to support@zkbridge.com. You can also follow us on Twitter and join our Discord, which you are able to see on our zkbridge.com, the official website. And thank you again, everyone, for coming. Thank you for being active developer in the Web3 world. And we would like to see more and more developers coming to build the ecosystem, build the zk ecosystem, build multi-chain ecosystem with us together. And thank you, everyone. That will be the talk for today.
Just want to do a test. Can everyone hear me?
Yeah.
And I also have a shared screen. Can anyone say that?
No, I can't.
Okay, now it works.
Yeah.
Yes, certainly.
So shall we start right now? Is from any organizer notice? Yeah, just want to ask the audience, can you guys see the screen? Can you guys hear us? Please say yes, then we can get started. Okay, so let me get started. So it's a great pleasure to be here to share Manta with all of you guys. It's really amazing opportunities. So today I'm going to introduce you Manta if you haven't heard of it. So we are the fastest zkL1 for the masses. And my name is Shumo Chu. I'm one of the core contributors of the Manta Network. So first, let me intro the structure of the workshop. So first, I will give a Manta overview. It's about 20 minutes. And I will reserve some time in the end of the presentation for you to ask questions. I will just like put the question in the comments, then I will read out it, and then and then after that, Brandon, our CTO, will present you the cryptographic research at Manta, and he will be share the journey of how are we developing the cryptographic both research and engineering, and how we improve the performance and user user experiences. And last but not least, Francisco will tell you the zkNFT, zkSBT, and proof keys, the core innovations to power the next 1 billion zkNFTs. So without further ado, let me get started. So first, before dive into Manta, right? Let me give you guys an overview of the existing zk landscape in Web3 today, right? So I normally kind of categorize that into 3 kind of applications. The number 1 application is privacy. So actually, the first zk project in the Web3 history is Zcash, or their paper name is Zerocoin, right? Brandon actually briefly mentioned the paper in his talk. And this is sort of an OG privacy preserving cryptocurrencies. And because zk, one of the killer features is zero knowledge, right? It can power many privacy preserving applications. So here I just list one of the few, but there are actually many more. So we have us, of course, Manta, and we have Alio, we have zkOpro, that's a research project from Ethereum Foundation, and we have Aztec, and we have Expresso, right? That's the first big category. And the second category is scaling, right? The idea of using scaling is we can using zk to compress computation, so that the computation is cheaper to compute, and despite the computation, it may be very expensive to compute, but it's very cheap to verify, right? All these sort of zk EVM, including zk Sync, Scroll, Polygon, zk EVM are into this category, right? And the third category is attestation, Oracle, and bridges, right? I didn't include every project here. So there is Sysmos, there is Axum, there's a HyperOracle, right? So, and where we are today, right? Why you want Manta? The reason here is that building, our mission is to get mass adoption for zk applications. And before I talk about mass adoption, let's see why we're not here. Why we're not here yet. So I think there are 3 difficulties currently preventing from mass adoption for zk applications, right? So the first is high barrier to entry for zk development, right? We have a team of amazing cryptographers, and you will see some of them. But not every developers and not every team has this luxury. Currently, you probably need a cryptographic PhDs to be able to develop some zk applications. So the second is a high gas fees, right? Even in Ethereum L2 is very high gas costs and also high prover costs. And third is we actually lack of toolchain support, right? So people are still need to have to write sort of a zero knowledge proof circuit. It's very hard to write. It's very hard to get it right, and very hard to get it efficient. So that's indeed the problem. However, we have a bright future looking ahead of us. So one of the reasons that the entire Web3 industry didn't get a lot of adoption is because of lacking of privacy, right? If you think about that, current way of doing things in Web3 industry is not great, right? Because for currently everything is public, right? But I claim here is that for every public Web3 activities, Web3 applications, there should be a private counterpart. And the private counterpart is way more valuable than the public counterpart. For example, for NFTs, right? So NFT, you can view NFT, at least part of NFT is art connection. Then for every NFT, every public art, there should be private connectors. And for every public marketplaces, including DeFi, including auction, including prediction market, there should be bidders, and there should be private bidders. And for every social activities happening in Web3, there should be privacy without like without any hesitation, without any justification. And for governance, that's also one of the biggest like use cases for privacy, right? Democracy doesn't work if there's no privacy. If everyone can see everyone else ballot. And also in DAO governance, I cannot imagine a world that every organization, the payroll is completely public like we are right now. So you have to have a private salaries. And also in games, right? So you can have public rules, but you have to have private state, right? All this above, right? All these amazing privacy preserving zk applications can happen in a blockchain. We don't get that right now, right? So that's essentially why we need Manta, right? So next, I will tell you in details how does Manta solve these problems. Yeah, like essentially that goes to the next part of my presentation is like why Manta. To remind you, the vision of Manta is that Manta is the fastest zkL1 for the masses. Why it's the fastest? It's actually in many regards, right? To partially answer the question I raised before, the three problems, remember? First, Manta is extremely high performance. We actually mentioned prover speed, right? We actually have fastest prover performance for private asset transactions. To remind you, we actually have 10x better performance than Zcash Zeppelin, one of the most advanced cryptocurrency for privacy. I think Brandon will actually dive into detail that how can we achieve that, right? That I'll leave the stage to Brandon a bit later. But this is actually makes user experience very smooth, which means whenever you create a transaction, it only takes 2 seconds to generate a ZK proof. And then your client, your Manta decentralized application will send this proof on chain. The second high performance part is fast verifier performance. We're building using a blockchain framework called Substrate, and it's written in Rust. And the virtual machine will be running high performance WebAssembly code. So we also get very fast verifier performance as well, and which lead to low cost. I think every DGen, every Web3 users really care about like pay less gas cost for your private transaction. And last but not least, right, to build a decentralized application on Manta, you don't need a PhD in cryptography because we provide high-level APIs and SDKs. So in the sense that our developers, they don't need to write a cryptographic circuit, and they can just using our SDKs and APIs to build your favorite decentralized applications. In the next slide, I can show there are a few built on top of us, but I strongly suggest you should be the next. And we have amazing collaboration with BNB Chain. So this is really a powerful emerging ecosystem incoming. That's the three reasons you should be on Manta, right? So how does this happen? So then I will dive deep into a little bit of Manta architecture, right? How does Manta work from a very, very high level point of view? So this is an overview of Manta architecture. So we built on the amazing blockchain framework called Substrate, right? We're using Substrate and Rust to build our blockchain runtime. Then on top of that is our zero-knowledge proof part, which is circuit. So we build this powerful Manta universal circuit, and this single circuit can power many decentralized applications and many private assets. The next layer is Palette. Palette is basically the private asset layer, and we build three kinds of private assets. One is Manta Pay, aka like zk fungible tokens, and second one is zkFT, and third one is zkSBT, which is sold bound tokens, right? And based on this palette layer, then we can onboard many amazing decentralized applications. So this is an incomplete list of applications we are currently already onboarded. So you can have like a read to earn, read on. You can have gaming and metaverse application called Multiverse, and you can have like a match to earn and anonymous dating app called AsMatch, and you have like a decentralized emails, which is DMail, right? And there are many more to come. And I strongly suggest you to build your own decentralized application on top of Manta. right? So that's the very, very high level overview of Manta architecture, right? Then I will switch gear a little bit to talk about protocol, right? To get down even deeper to see like how does Manta protocol and what are the Manta product and what are the features of the Manta as a layer 1 you can use to build your own decentralized applications. So the next, that's a Manta protocol overview, right? In Manta, everything is around the zk asset ecosystem. And within the zk ecosystem, so I need to introduce two concepts to you guys. Basically, zk asset and the zk address. So, so this is a very overly simplified view of zk asset and zk addresses. So in Manta, on top of the private address, on top of a private asset, you have a zk asset. So I will tell you precisely later what is a zk asset. But from the high level point of view, zk asset is an asset on blockchain can preserve your privacy. So the zk asset include zkFT, and which is zk fungible tokens. You can think of from the first approximation like ERC20, and also you have zkFT. From first approximation, you can think of like ERC721 and ERC1155. And that's the asset part. And from the user perspective, we have a zk address system which hold and control your zk asset. So you may say, hey, like why you need a new asset and address system? Because fundamentally, how the zk asset and zk address work is different from your public asset system. So because your zk asset is private, right? So then you need to find a way to view your asset, because your zk asset cannot be viewed on blockchain. We need to define a viewing key protocol to actually to allow yourself and to whoever you want to give them the viewing right to view your private asset. So this zk address contains, so that's why you can see, compare with the public address system, the zk address system contains a spending secret, which is normal, like your mnemonics. Also, it contains a viewing key. And this viewing keys allows you and others, if you want to let them view your private asset, to view your asset. That's a new cryptographic construction, right? So that's the overview of zk asset. So from the high level, zk asset is your private asset. It contains fungible tokens, NFTs, SBTs, and the zk address is the control system for your zk asset. It can allow whoever you want to view your zk asset, and it has a spending right. So then let's dive deeper into zk asset. So you might say, hey, like what is zk asset? So zk asset is actually our innovation over the previous similar zk asset system. So there is a little bit history, right? So of the evolution of the zk asset system. So the first generation privacy coins, you have Zcash. And Zcash is a single kind of fungible tokens. The next iteration of the zk asset system is called a MASP. MASP is short for multi-asset shielded pools. And from the name, you can infer that the difference between MASP and Zcash is that MASP support multiple kind of fungible tokens. So, and our Manta zk asset actually indicates the third generation of zk asset system, which have even more flexible asset types. So yes, we have fungible tokens, and yes, we have multiple kind of fungible tokens. Actually, you can have arbitrary fungible tokens within different ecosystems. For example, you can have zkETH, you can have zkMatix, you can have like zk Solana, and you can have, for example, zkUSDT, right? That's multiple kind of fungible tokens. And also we have NFTs. So we can have NFTs and we have SBTs, so that you can, for the first time in history, you can put your fungible tokens, your favorite fungible tokens into zk, right? That's the first. We have very, very flexible asset types. And second, it's privacy by default, which means by default, no one can see your asset on-chain ever, right? And third is disclosing at will. What does that mean is that, as I previously introduced, we have a viewing key system. This viewing key gives you the power to view your asset. And maybe you can say, hey, you give your wife need to ask your, hey, like which kind of private coin you own. You can give your viewing key to your wife as well, so your wife can view your like all the private assets as well, right? Basically, you can give the power of whoever you want to view your private asset. And last but not least, you have a configurable asset policy. You can define the asset policy yourself to who can view and who can see your transactions. So that's the ZK asset. And next, for the ZK address system that controls your ZK address, the ZK address system controls your ZK asset. Again, from the high level, this ZK address is also an innovation over the previous generation of the private preserving cryptocurrencies. So first, this ZK address is reusable, which means that you can just use your ZK address as your public address. So you don't have to generate new address each single time for privacy. That's a fixed address. That's a fixed public and reusable address you can post on your website. You can post on your Twitter to ask people sending money to you, right? So second, it's independent, right? This ZK address is not attached to your public address system. So which means you can transfer money and transfer cryptocurrency between any public and private ZK address system. This ZK address is not attached to your public address. And third one is audible because they have a viewing key system. I believe Francisco will give you a much more detailed technical overview for the viewing key and address systems in his talk, right? So that's about the ZK address and ZK asset, and from the user point of view, what you can use for Manta. And then I guess last but not least, all the developers can leverage the API we provide to manipulate and to do all this kind of like activities over the ZK asset, so that you actually. So what is the mechanism to convert ERC20 to ZK asset? Go to Manta Pay. Press one button. So for depending on where the ERC20 is, if it has a bridge asset, you need to do through the bridges. But in general, after you bridge the asset to Manta, one click, and our Manta wallet will generate zkP. And after you generate zkP, boom, you will convert your like a ERC20 to a private asset. Thank you for your question, sir. Okay, so next I will show you a little bit more details of how do we think about the protocol and how does the protocol is constructed. Okay, thank you for the question. I will answer your question last. Okay, let me dive a little bit deeper into the protocol, right? So you can see the core innovation we have is that we have a private asset that is native composable with public account, right? So this is a pretty hard problem to solve here, because to maintain privacy, we have to use a model called UTXO. Basically, instead of a single account, you have distributed and discrete private coins, right? So, and also you still have a public account. You need to pay gas fees. You still have public asset. So Manta Pay is sort of kind of like a resolution layer between your private UTXOs and public account, right? So let's also dive another step deeper, right? So basically, we create a concept called transparent UTXOs. The transparent UTXO model is an amazing model for private and public interoperabilities. Basically, the Manta Pay consists of two parts. One is a private UTXO-based storage, and one is zkP verifier. We use a very fast Gross-16-based Poseidon hash-based proof generation implementation to generate proof. And then after you generate your zk proof, the zkP verifiers verify proof. And after the zkP verifies proof, it will transfer to actions into the UTXO-based storage. It could be for the previous gentleman asked, like converting your ERC20 to a private coin. It could be do a private transfer between two accounts, and it also could be doing converting your private coin to public coins. Basically, Manta Pay is sort of the resolution layer between the private UTXO models and your public address system and public account systems, right? So we go one more layer deeper, right? This Manta Pay resolution layer, because the circuit we define is universal, it can support various kind of token standard, including ERC20, ERC721, and ERC1155, right? So, and another cool properties of this universal privacy circuit is that it actually not only allows private token transfer and private minting and proof of ownership, all this function we have now. After we adding EVM, so then we also have EVM plus zkP execution layer, and you can bring programmable privacy to Manta, right? So I think that's the high-level overview of Manta protocol. And next, I will like pass the mic to my colleagues, and they will give you deeper dive on the cryptographic research and as well as how the Manta zkSBT work. And last, let me move to the Manta community page. Please join Manta community by following on Twitter. And we read like extensive docs if you want to develop in Manta, and also please join our Discord. And to answer the previous gentleman questions, right? So okay, so I think we answered some of the question over the chat, right? Okay, one more question. Any more questions on Manta overview? Okay, awesome. So then let me pass the mic to my colleague Brandon, and he will talking about our cryptographic research. How can I end? Okay, stop screen. Great.
Thanks, Shumu. Let's see. Can everyone see the slides? Okay, great. Hi, everyone. Thanks for the organizers putting this conference together, and thanks for everyone for being here. My name is Brandon Gomes. I'm CTO at Manta Network, and I'm really excited to talk to you about Manta and our journey to building the fastest zkL1. It's been 2 years in the making, but we're really excited to talk about it and to show you how we got there, the new paradigms we've ushered in, the new open source tooling, and lots of new optimizations that we made to get here. So over the past few years, we've been working hard at Manta to build the most user-friendly privacy protocol in the blockchain space. We started with our original white paper, improving over the zero-coin protocol, as Shumu mentioned, and we built out a novel private transfer protocol and anonymous ownership proof protocol as well. Along the way, we noticed that there was a really large lack of tooling in the space, and we also built out OpenZL, this middleware open source stack, to make it really easy to build production zk protocols and integrate with all the open source tooling that's out there. Once we solved those interoperability problems, we tackled the performance issues inherent in zk applications by architecting the ZPrize WebAssembly track that targeted performance bottlenecks in browsers for proof generation. And now today, after bringing together all the efforts of our fantastic team, cryptographers and engineers alike, all those in the cryptography community, we have what we think is the best user experience out there. So let's dive in. So from its inception in 2020, Manta has been innovating in the privacy space, bringing together lots of different ideas from different protocols together to create what we call this universal privacy protocol that supports user-generated assets and is adaptable for future situations where you'd want to have anonymous smart contract execution, where we think you can expand the private payment protocols to sort of all of DeFi, and eventually to much, much broader applications like the ones that Shumu mentioned, things like DAOs and games. So this fundamental primitive that we created kind of sort of expands and fills this whole space of ideas. So our initial spec included a multi-asset version of Zerocoin. This was sort of the first step in getting to this new design. And then we created a new UTXO model compatible with privacy-preserving exchanges. So we made sure that when we created it, that it would work with exchanges at least. and you sort of get a private atomic swap out of the box. And it's also some inklings into this future anonymous smart contract execution protocol that we are developing in the background. So this new protocol allowed us to extend the vision of privacy for something beyond just simple transfers, beyond the original private Bitcoin vision that was where Zcash was coming from. So we made it integral to the protocol that privacy be something that's applicable to just to user-generated assets in general, and not just to sort of like the underlying token of the blockchain like Zcash, and eventually to any future smart contract layers. So later on, we perfected this design and created the protocol that you see today. So this is sort of the picture of what a protocol looks like now. So we're iterating over those original ideas in the white paper. We started to concretize the protocol and build out our first prototypes in the first few years of development. So the first thing we did was we used the latest in the ZK-friendly hash functions, like the Poseidon hash function, and we simplified the UTXO protocol a lot from Zerocoin, and so we were able to get a performance improvement over original Zcash by about 100 times. This is a great sort of moment that we found that we were able to reduce the complexity a lot, and like we see ourselves being able to get sort of 1 to 2 second latency in user transactions. So this is sort of a huge like booster for us, and we found that sort of the things that were thought to be impossible before might actually be possible. We also included some new techniques in our protocol for improving the long-term synchronization, synchronization times that are experienced by most privacy-preserving blockchains. When you have private UTXOs on chain, nobody can see who owns them, and so you have to sort of go through and check each one to see which ones you own. So we really spent a long time and talked with a lot of people in the space to find sort of the optimal protocol for this. And we came up with a new scheme, basically replacing the traditional Merkle tree accumulator with something called Merkle Forest that lets us tune the privacy performance trade-offs in the best way. So in certain applications, you may want like a huge level of privacy, but in other applications, sort of the way that it's built, you may not need as much privacy, and so you can trade that off for speed. So we built out that primitive and to strike sort of the appropriate balance for users. We also added a prover-signer separation protocol. This is another extension above original Zcash, so that it allows us to integrate with hardware wallet support, protecting users from untrusted ZK provers and preventing them from being able to steal funds. And so you could plug in your hardware wallet and just sign your transaction to make sure that no matter what the prover did, they wouldn't be able to take your funds, and the hardware wallet would still have the final say on whether the transaction was valid before submitting it on chain. So once we took all these ideas together, we built out that protocol in Rust, fully in the open, and integrated to the MantaPay palette that's live on Calamari today. So that's sort of where we get from. And Francisco will talk more about the zk NFT SBT protocol and the proof key framework, which are powered by this universal circuit, and how we can leverage our protocol to build your own tokens and your own NFTs. So as we were developing these protocols, we kind of realized that there were a lot of missing pieces in the open source stack. So as Shumo mentioned, there's a huge barrier to entry for creating your own applications, especially ZK applications from scratch. So we kind of had to find a way to rise above these barriers. And so we built OpenZL. So those initial prototypes, we already knew that the ZK space moves incredibly quickly, as some of you may notice these days. Basically, new protocols are being created every few months. Exponential improvements are being made at like extremely rapid pace. So to keep up with the innovations from the academic side, we experimented with tons of open source libraries, but realized there was a large gap between academic code and production level code, especially in the way that developers write circuits. So we asked ourselves a really simple question. If a new fast protocol comes out tomorrow, how long would it take us to switch our protocol to the new one, right? And given to the state of the art at the time, it would probably take weeks or months with lots of developers, lots of engineering time, and making the iteration really costly and time consuming. So instead, we thought, how can we define our applications in a way that's independent of these protocols? So in case if a new one comes out, we can upgrade super quickly, or at least get a prototype really quickly. And how can we test our applications over all these different protocols to find the best performance trade-offs? Sometimes in one protocol, the way you write your circuit, it's best for one proof system, and in other cases, being best in a different proof system. So how do we make sure that we can actually test this and like actually get performance numbers? And basically, we saw there was nothing in the space for this, and so OpenZL was sort of came out of this issue that we were having, and so we created this tool for everybody to use. So this is sort of a big picture of OpenZL. It's a middleware framework that was created to tackle the three main problems in zk application development. First being no interoperability for common circuits, a large gap between proof systems and domain-specific languages for defining zk applications, and an ever-increasing security surface. As we write more and more code has to be audited, and the higher risk for security issues in your code. So OpenZL is this modular toolchain stack that sort of tries to tackle these three problems. And it's made of 4 key components. The first being Eclair, the embedded circuit language and intermediate representation, which is a language for defining circuits in Rust that's agnostic to the proof system backend while retaining maximum performance. So this is really the thing that was solving the initial problem. I want to write my circuits once and test them with all sorts of backends. Once we built this Eclair language, we then wrote all our circuits in Eclair and integrated them into these different plugin frameworks to get our specific like production-ready system. So the first part is proof system plugins. So this kind of infrastructure lets developers plug in their favorite proof system into OpenZL, like ArcWorks or Halo2, if you've heard of those. The next part is the language plugin. So being able to integrate with Circom or Noir, you're able to write components in Eclair or components in Circom and make sure they can talk to each other. And finally, a security plugin infrastructure for easier static analysis and tools like Veridice's Picus that lets you check your code, check your circuits, and make sure they're safe. So OpenZL is sort of bringing all these pieces together, and so you write the least amount of code necessary to get the advantage of all these parts. So let's take a concrete example. Let's say you wanted to write a simple Zcash sapling clone in Rust. So in OpenZL, you take the simple pieces of the circuit, write them in Eclair, probably take you about 200 or 300 lines of code. And then in that one library, you could generate ArcWorks provers and verifiers, deploy those verifiers in a palette, and compile the prover to Wasm and deploy in your browser. So in maybe an afternoon or two, you could get sort of a working prototype. And then taking that code to production, you'd use all the different backends to test which one makes sense for your application, maybe ArcWorks Gross16, Halo2 KZG, or Plonky2 Fry. Those are some of the options you have available today to see which trade-offs make the most sense for your application. So OpenZL is currently available on GitHub, and thank you to the Polkadot Treasury that sponsored development of these libraries. You can find out more at openzl.org for documentation and use cases. So after we built OpenZL to make our development more modular and agile, we started tackling the actual performance problems many modern privacy applications face. So to gain widespread adoption, privacy needs to be invisible, right? It needs to be as easy to use a privacy-preserving application as it is to use a transparent one. Users won't, make the leap in using privacy applications if they're too expensive or too slow. So right now, most users use wallets like MetaMask and Talisman in the browser. So we looked for a way to make proving time faster in that domain. So while we were thinking about this, Aleo sort of at the same time was creating a new competition for improving the performance of zk protocols called ZPrize, and we sort of think, okay, great, let's work with them and find a way to get people interested in improving performance for the WebAssembly use case, which is for the browser. And so ZPrize was formed and built this public competition for accelerating the future of zk cryptography, and sponsored by and architected by all these big players. I'm sure you know a lot of these people, a lot of these companies. And so we created the Wasm division because we knew that this was the highest leverage way to improve the user experience. So along with architecting the prize, we built our own standard benchmark in collaboration with Jump Crypto. And the state of the art for common systems like ArcWorks and Halo2 is to compile Rust to Wasm using tools like Webpack. And when we benchmarked our largest circuit, we found about 10x slowdown with this method. So we took the most expensive part, which is the multiscalar multiplication, and through all the optimizations we knew at it. So things like batch define, GLV, fast SIOS, Pippinger tuning, all these techniques, we were able to get about 5 to 7x speed up over the native Wasm, so bringing us about the same performance you expect from a CPU. So we went from 20 seconds to 3 seconds proving time in the browser, and so when you run the application, it's extremely seamless, and you won't even notice how fast it is. So all of our code for ZPrize is open source. You can check our GitHub. Please check it out if you're interested. And finally, after years of work, we've achieved our goal of the seamless privacy experience on Polkadot. We have the fastest provers using techniques from ZPrize and OpenZL and other improvements that we've learned about and shared with the community to this day. We have a new privacy-preserving wallet extension coming soon that will deliver seamless payment experience in the browser with future integrations in your favorite dApps. And we'll continue to make upgrades to the prover and on-chain verifier as the new software and techniques come out to reduce the time and costs of private transactions. So that's our journey, and hopefully you'll join us in the next phase of Manta Network, going into the future. Please explore the ecosystem on our website at manta.network/ecosystem. You'll see the projects we're working on, the partners. So thank you again for having me. And I think we have a few minutes left, so I'll take a few questions from the audience. Okay, I don't think there's any questions. So perhaps I should hand it off to Francisco.
Yeah, thank you, Brandon. Can you see my slides?
Yeah.
Perfect. All right, then let's get started. So, hi everyone, and thank you for you all for being here. My name is Francisco. I work as a cryptographer at Manta Network, and I'm going to tell you about the ins and outs of one of our new products, the private NFTs, and the also called ZK NFTs. So let's start with some motivation. Why do we need ZK NFTs? And actually the question should be, why not? Because privacy should be the default when it comes to asset ownership in general. The same way you don't share your bank statement with your next door neighbor, or you don't want your partner to know how much crypto you're holding, you should be able to choose to whom and when to disclose that you own a certain NFT. And then if we want an actual application that can be done with ZK NFTs that traditional NFTs can't, it would be verifiable anonymous identities. So in this case, we can link our identities to zkSBTs in Web3 applications such as the dating app as Match. And in this way, the fact that the zkSBT ownership is private detaches the SBT from the owner's ZK address. And then using the power of zkPs, we can run identity verification protocols against on-chain data if that's necessary. Now let's dive into the proof key protocol, which is this identity verification protocol I was telling you about. So for that, let's briefly recall how Manta's transfer protocol works. So first of all, as Sumo and Brandon mentioned, it uses the UTXO model, which is just a cryptographic commitment to a ZK address, the asset, in this case the zkSBT, and some random number, which we call salt. Then, as a user, we first create a transfer whose data is private, so you don't want this data to be known. to the public with all the information about our transaction. So in this case, we've listed the sources and the sinks, which are the public accounts involved, and then the senders, which whose UTXOs we're spending, but we don't want to leak which UTXOs in particular, and also the receivers, which are essentially the zk addresses of the receivers of the transaction, so who we're sending the money to and how much money we're sending. So then we pass this information to the prover, which in turn generates a transfer post, which is just the name of those parts of the transfer which are public, so which can be shown. And in this case, for example, we can see that the sender becomes a sender post. So while the sender is the UTXO we're spending, the sender post is just a Merkle tree root of to which this UTXO belongs. And also it contains a nullifier to prevent double spending. And the receiver, on the other hand, becomes the receiver post, which hides the zk address of the receiver, but shows the UTXO that we create on his name, and which will be inserted in the Merkle tree together with the encrypted node. Now let's go back to the proof key protocol. So this protocol consists of two steps. In the first step, we will show that our zk address owns the zkSBT, essentially retrieving transaction data. In the second step, we will show that we have the spending rights to that zk address. So in other words, that we know that the corresponding spending key from which the corresponding spending key from which the zk address is derived. It's very important to know that note that the second step must involve some random challenge from the verifier to prevent replay attacks. Now, for each step, we have two actors, the prover and the verifier, and three phases. First, the verifier sends a randomized challenge to the prover. Then the prover generates a proof responding to that challenge. And finally, the verifier verifies the proof against the challenge and on-chain data. Now, let's start by explaining the transaction data step. So the prover sends the verifier a transfer post, which contains the UTXO to which the zkSBT is committed. The prover now opens the node with their viewing key, something they can only do if this UTXO is committed to their zk address. From the node, they can retrieve the random salt in the UTXO, which then they send to the verifier. And now the verifier simply computes a UTXO with this salt, the zkSBT and the zk address, and checks that this UTXO coincides with the original one in the transfer post. And then the second part. This only proves that the zkSBT belongs to the zk address, but the prover still hasn't proved that they have the spending rights to that zk address. So now this second step is a little bit more involved. So first, the verifier sends the prover a virtual zk asset and some random salt. And what do I mean by virtual? By virtual, I mean that the zk asset doesn't exist on-chain, since we only want the prover to prove that they can spend any asset owned by the zk address, but we don't want to force them to actually spend any. Then the prover computes a UTXO using their zk address and the challenge zk asset and salt, and inserts this UTXO in an empty Merkle tree, which acts as the virtual ledger. Then they generate a to public transaction. So that is a transaction with no sources, two senders, one receiver, and one sink. So by sink, it means you take money from the shielded pool back to a public account, and this spends the UTXO he computed before. And now, why at two public? Well, because a two private, namely minting into the shielded pool, doesn't bind the spending key to the zk address, and because a private transfer is computationally more expensive than a two public. And finally, the verifier runs a series of checks on the generated proof. First, that the transfer post shape is a two public, that the signature and the zkP are valid, and that the root of the Merkle tree in the sender post is that of a Merkle tree with only one leaf, namely the one created from the zk address, zk asset, and salt. And note that we've done all this without anything else other than the two public circuit in MantaPay. And finally, let's wrap up with a concrete example of how an app may use the proof key protocol to take advantage of the verifiable private identities. So in this case, a user will use the MPO service, which stands for NFT Private Offering, to mint a zkSBT without revealing their public account. So MPO is simply a third-party minter. Then they want to use this zkSBT as their identity on the dating app as match. So when a user tries to log in, as match sends the SBT ID to a verifier service, which prompts the user to send a valid proof key. And then they send the proof key seamlessly from the MPO backend, which then the verifier service checks against the blockchain data. And if this verification is successful, the user is allowed in as match. And this is all. Thank you all for your attention, and feel free to ask any questions. Well, if there are no questions, let's leave it here. Thank you again, guys.
Hi, Richard. Hi, everyone.
Hey, how's it going? Mic's working?
Yeah, I can see you. I can hear you clearly.
Perfect.
So the workshop from Chainlink Labs will start soon, brought by Richard. And so maybe, Richard, you can introduce yourself in Chainlink. I think you mute yourself. Yeah, you can get started if you want.
Yeah, sure. So yeah, I am Richard Gottlieb. I'm one of the developer advocates at Chainlink Labs. And yeah, we're going to talk about what is Chainlink today, go through the different products Chainlink offers, take a look at some live code demos of those products. I love interactive conversations. So if you have questions, I know we're streaming live on YouTube. If you can pop those into the chat there, I'll do my best to answer them. And yeah, I guess let's go ahead and get started. So we'll start off with a short presentation. It's kind of like eating your vegetables first when you're at a meal. It's the boring stuff, but hey, it'll get us a good base layer for where we're going. And then from there, we'll dive into some like actual code examples, going through our documentation, looking at how to actually use the different products. So first thing, what is Chainlink? That's going to be what we're covering today. And I like to start off first. I'm sure everybody's familiar with what smart contracts are, but just kind of to make sure that everybody has the same foundation, go through a talk about what are smart contracts and the purpose of them, super high level. So smart contracts, as the name implies, are contracts, that's agreements between two parties. Traditionally, in the world of contracts and agreements, there's a third party who sits right there in the middle, and they're the one who kind of has to be the arbiter of the contract, right? So you have information, you have the participants of the contract, and you have somebody who makes sure the contract actually happens. Personally, I'm in the United States, and things here in the legal system usually work out just fine if you have a contract. You don't have to worry about it. But even that small little piece here of usually kind of bothers me. I don't like it, you know? I'd like to know that 100% of the time, if I have an agreement with someone, it's going to happen the way that it's supposed to happen. And I know around the world that reliability of the legal system can vary quite a bit. So that's where smart contracts come in, right? They have this contract that sits in the middle that's going to be based on cryptographic truth instead of trust in that third party. And so that's kind of like the foundation of why I think smart contracts, blockchain, and what Chainlink has to offer is so important and powerful. But we have this idea of consensus. Now, consensus means agreement between two parties. I love giving this presentation to live audiences, but just mentally play along with me here. I'm going to ask you some hard questions. What's 1 + 1? It's not a trick question. 1 + 1. It's 2, right? I think it's 2. Hopefully you agree with me that it's 2. And so that would be you and I reaching consensus if we both agree. So pretend that we are nodes in the blockchain, right? And we all get asked this question. What is 1 + 1? We all agree it's 2. This is great. This is easy for blockchains to deal with. We can all agree on that. This is what's called a deterministic value. Doesn't matter where you are, when you ask this question, 1 + 1 should always be 2. Unless something like drastically changes in the fabric of reality, it's going to be 2. Now I'm going to ask a harder question. Yeah, Kate got it right. It's 2. What's the current temperature? It's a lot harder question, right? Like I'm looking to see here where I am, it's 71 degrees Fahrenheit. It's maybe different where you are and when you are. And when I say 71, I mean outside, not inside, right? So that depends a lot, right? So what's the current temperature? It depends. That's a non-deterministic question. Anytime you can answer a question with it depends, it's non-deterministic. And if we're all different nodes in the blockchain now, and we get asked this question, what's the current temperature? That can be really hard for us to all reach agreement on, right? Because it's probably not the same where you are. This brings me to blockchains. They remind me of Genie from Aladdin. They have all this phenomenal cosmic power. Great things can be done with them. Itty bitty living space though, because they have to rely on deterministic values. This is what's called the Oracle problem. It's bringing those non-deterministic values into the blockchain. And if you think about it, really, a lot of the real world is non-deterministic, right? Even if you think about like, what's the value of, I don't know, an iPhone, for example? Depends. right? Everything depends pretty much. So the Oracle problem, the solution to them, kind of ironically, I think, is oracles. They're what solve the Oracle problem. And that's what Chainlink is. It's an Oracle network. So we have here our data sources on the left. Those are going to be your non-deterministic values, right? Things like temperature. It's that first example there. We need some way to get them into our blockchain, the decentralized computation, right? It doesn't matter what blockchain it is, but we need some way to get them into those blockchains. And you can do that with a single node. It's possible. Like it would work. I could set up a server here in my office, and I could run a server that would bring off-chain information on-chain. So non-deterministic values, I can bring them on-chain. To me, that's kind of a weird solution because you're taking decentralized benefits and you're centralizing them right there with that single node. That introduces it as a single point of failure. And again, at the beginning, I mentioned wanting to be based on cryptographic truth and not trust. And with one node, you're basically introducing that trust back in because you're relying on that one node. So what Chainlink does is it kind of stands in the middle there as a distributed Oracle network. So the Oracle nodes from Chainlink, they act similarly to the blockchain itself, right? We have individuals running nodes and they all come to consensus and then they pass that information into a smart contract and bring that information on chain. So we just kind of blaze through that bit there. If you have questions, feel free to pop them into the chat. I'll do my best to answer as we go along. I normally pause for questions, but I think there's probably enough delay here that it would be too long of a pause. So just pop them in there and I'll answer as we go along. So what does Chainlink offer? Well, the first thing we offer are data feeds. And data feeds, kind of as the name implies, is going to be bringing that data on chain. Probably the most common use case we have are asset pairs. So when I say asset pairs, what I mean is like BNB in terms of USD, right? So two assets paired together. What's the value of BNB in terms of USD? And we can take a look at that here in just a moment and what that looks like. And I'll explain how consensus is reached when we take a look at that actually in a moment. The next thing that we offer is VRF. It's a verifiable randomness functions. It's going to be bringing that random values that are truly random and provably random onto the blockchain. Now, you might be wondering, well, I have blockchain, I have ways of generating randomness, right? I just need some sort of seed and I can generate randomness on the blockchain. Sure, you can, but it's not real randomness. And what I mean by that is this. If we take a look at this example, we have a user here on the right who's interacting with, we'll just call it like a dice rolling contract. And we have the miner on the left who's going to be mining those blocks. When you have an environment that is deterministic, like the blockchain, you can have, the miners need to actually put their blocks into the blockchain. And while you have random values that can be generated, the miners kind of have the ability to determine if that value is then added to the block that they're mining. So in practice, what this would look like is if I had a dice and I were to roll that dice, I can't determine what the value is going to be, right? It is a random value. But if I had the ability to continue to re-roll until I got the value I wanted, then effectively it's not a random value anymore, right? Because I can control that. So while the values being generated are random, being able to control what value is then returned, that kind of removes that randomness. So Chainlink VRF, it steps in there, and within the Oracle network, the random number is generated, the proof of how it's generated, both those things are submitted back to the blockchain, and that's what's recorded. So it's done separately from the actual blockchain itself. So you have provably random numbers. We have a question here about our Chainlink Oracle, and Grammarly is blocking the other bit. Hold on, sorry, trying to get that off my screen. Can't move it. Our Chainlink Oracle and external adapters qualified to Bounty. So yes, if you, to the Bounty question, well, let's answer that now. To qualify for the Chainlink Bounty, if you use a Chainlink product to make an on-chain state change, then that will qualify. So as long as you are using it to actually make a change to the blockchain, that's what we're looking for. Hopefully that answers your question. Great question. All right, so we've got our verifiable randomness function here, our random numbers. We also have automation. And automation is really, really useful and really cool because, like the genie, smart contracts are extremely powerful. Like me, they're also extremely lazy. Smart contracts won't do anything by themselves. They always need something to be causing them to instigate that function to be run. And that's where Chainlink Automation comes in. So we'll take a look at Chainlink Automation in our demos here in a minute. There's two main ways that Chainlink Automation works. The first is going to be, there are time-based automations, which are going to be based on the Unix cron time scheduler style of scheduling. Essentially, it's a job scheduler. So you can use the Oracle network to ensure that your function runs at a given time. The other one is a custom automation where you can, within your smart contract, set up a function that will return a Boolean of true or false, whether or not you would like this function to be run. And then based on that logic, it will then run the function. So these are more useful for if you have some series of events that you want to have taken place first, then for this function to be run. With those custom automations, they'll be checked every block. So every block, you'll have a check that goes through and says, hey, does this need to be run? Does automation need to be run? If your function comes back true, then yes, that will need to be run within that next block. So it's constantly checking, but it only runs when it actually returns true from your function. And we'll see what that looks like here in a minute. So that is the three main things that we're going to be talking about today. So price feeds, VRF, and automation. While we switch over to looking at the actual demos, any questions, pop them into the chat. So first, we'll take a look at data.chain.link. This is going to be our data feeds. And we'll take a look at, we were talking about BNB, or that's BUSD. Let's take a look at ETHUSD since it's right here on the front. So we talk about data feeds. This kind of gives a good visual representation of how data feeds work when it comes to these price asset pairs. On the right side of the screen here, you can see the different oracles, and you can see they're all reporting different values, right? So this comes back to that non-deterministic question, right? If I were to ask you, what's the value of ETH in terms of USD? Well, it depends, right? There's different values coming back here. How this gets turned into a deterministic value is essentially each of these different oracles will report their answer to the given question. With that, then you have a consistent set of inputs that you can find an answer from. So you're taking a non-deterministic question and answer of what's this value, turning it into a deterministic one, because we're saying, given this set of inputs, what is, and the example here we actually use is the median value. So given a set of inputs, what's the median value, right? And that's something that will always be the same. It doesn't matter when or where I ask you that question, that will always be the same. So that's how we kind of, with this example, take the non-deterministic, turn it into deterministic. A couple other things to look at here, just to kind of explain how data feeds work. You'll notice there's these trigger parameters. So for this specific data feed, if the price deviates by 0.5%, that would cause it to update the value on chain. Or if the heartbeat occurs. So I think it's about an hour. So if an hour passes and there is no update, it'll go ahead and force an update anyway. You also have here the oracle responses. So you can see there's a minimum of 21. So in order for this to be considered a trusted answer, we need 21 different oracles to respond. Currently, it's 30 out of the total possible 31 that are responding. So you would be meeting that threshold. So that kind of explains how data feeds work. Common questions we get around data feeds, and you'll see this when we get into the demo in just 1 second, is, what does it cost to use a data feed? So the neat thing about data feeds currently is that when you have something that makes a change to the blockchain, that's what's going to cost you gas, right? When you're just reading a value off the blockchain, that's free to do. So data feeds are updating a contract on the blockchain that you can read from. So you can use them in your project fairly easily, and they'll be updated by the Oracle network. So if you wanted to use a data feed, how do you do that? Well, if you head to docs.chain.link, you can see here all of our documentation. And I'll be honest, I use this all the time. This is where I go for pretty much everything when it comes to using Chainlink products, because things change from time to time, so it's always good to make sure you have the current information. Also, I don't know, I really like how our docs team writes the docs, and it's super easy and friendly to use. One thing to note here on our main page is you may notice there's this available on. It shows which networks things are available on. You'll notice that Chainlink Functions, which is brand new, is only available on a couple networks in a beta right now. So that's just something to keep in mind, but you can kind of get a sense for where different products are available. So if we were to click into data feeds here, we could go to this using data feeds example down here. And this will let you know how to use data feeds on EVM chains. And you'll see here, there's a sample contract. And it explains everything about it. What's awesome is Remix. I don't know if you're familiar with Remix. If you're not, it's a fantastic tool, especially for getting started. It is a browser-based IDE, and it makes things really easy. So with all of our docs, you can go ahead and just click Open in Remix, and it will open that specific example in Remix for you, ready to go. Now, one thing to note about our documentation is the examples are all going to be based on Sepolia. And sometimes that matters, sometimes it doesn't. So for this example, you'll notice here that for the price feed, it's talking about getting the Bitcoin in terms of USD price, and it gives you an address here. Now, each different asset pair is going to have its own address, right? Because that's going to be where the oracles are reporting back to that aggregator. So let's go ahead and look at how would you find like BNB in terms of USD, right? What would we do for that? Well, we head back to our documentation. You'll notice here there is a section called price feed addresses. And on here, you have a bunch of different chains. We'll take a look at BNB chain. You have the mainnet. You also have down at the bottom, there's a lot of different options here. You also have the test chain. Cool. So what if we want to grab BNB in terms of USD? We'll need this address right here. So just for completeness, I'll go ahead and change the comment here. Oops, typing is hard, especially when you're on camera. So we'll go ahead and change our addresses, right? So what is this contract doing? We have our constructor, it's setting up that price feed. And you'll notice that we import in this aggregator v3 interface. What that is, that's an aggregator contract, right? So that's the thing that takes from the oracles all the different responses and aggregates them together. And then we get to the function that we'll be using, get latest price, excuse me. And it's a pretty basic function. There's a lot of comments here. And I'm curious, I'll give you all a minute to answer in the chat if you know why these comments are here. And I'm just curious, anyone knows why? It's a fun little like solidity trivia for you. So we have our price feed. We have the function to get latest price. It's going to return the actual price for us, and then we'll return that back out. So this will show us what the actual price is. If you want to follow along, one thing to note within Remix is that I have autocompile turned on. If you don't see this green check mark, you'll have to click compile or turn on autocompile. And then we can go to actually deploy. And let me make sure I'm on the right network. Yes, okay. We'll change to our MetaMask provider, and we can simply deploy this contract. All right, so we have our price consumer here deployed. And you can see it has our one function of get latest price. One little bit of facts for you if you're not familiar with Remix is orange buttons, those are going to cost you gas. The blue buttons, they're normally free because they're a view function. So we click get latest price. We'll see the current price for BNB is listed as a really, really large number. Now, before you get too excited, this is a correct response. The reason it's so large is because Solidity doesn't have the concept of decimal places. There are no floats in Solidity. It only deals with integers, like whole numbers. So when it comes to increasing precision, the way that this is often handled is by multiplying it by a factor of 10. In this case, it's going to be 10 to the 8th power. So you'd have to take your decimal here and move it over 1, 2, 3, 4, 5, 6, 7, 8 spots and put it there. Normally, when we're talking about a fiat currency like USD, it's going to be 8. And then if we're talking of two things, like if we had BNB in terms of ETH, for example, two different tokens like that, then it would be 16 because you can be more accurate with those. So that's how you can get the price feed. It's pretty straightforward. Looping back around to my pop quiz, I don't know. I don't see anybody who answered my question. The reason why these are in here as comments is because if you're familiar with a language like JavaScript, for example, the way that this function signature would look normally is because it would have underscores like this, right? Because you have a bunch of values that are going to be returned, but we don't want to use them. In Solidity, what this would look like if we didn't have these comments in here, it would just be a bunch of commas, right? And especially if you had them all on one line, this would look like really, really weird. You know, it'd be, this is the proper way to do this function. And that just looks really weird and it's super confusing, especially in your documentation. So that's why those comments are in there. Just a fun little Solidity fact. If you ever see something that looks super crazy like this and all these extra commas, that's what's going on. You have this latest round data returns a bunch of values that we aren't using in our function. If you had them in here, then you would get a warning from the compiler saying, hey, you have unused variables. So in order to make everything happy, there you go. All right, so any questions about price feeds? Remember, things to remember are the address is going to be what determines which price feed you're actually looking at. So that's going to be asset pair and chain dependent. Give it just a second for any questions. Okay, if you have questions still, feel free to pop them in there. We'll go ahead and leave this remix and we'll move on to VRF, so Verifiable Randomness function. So VRF, the way that it works is you're going to have a VRF coordinator contract that you will be essentially, you'll deploy a contract, you'll ask that coordinator for a random number. It'll say, cool, goes off to the Oracle network, and they'll come back to you into your contract with that random value. Some things to remember with random values. We mentioned about the miners, you don't want them to be able to influence it. When you get your random number back, if you need it to be a truly random number for a reason that you want, something like you are minting an NFT and it's like the rarity, for example, you want to use that random value immediately. So in the same function that receives the random value, that's where you want to actually do something with it as well. We'll see what that looks like here though. So in our documentation again, you can read all about VRF. For the sake of time, we're going to skip right to getting a random number with the subscription method. So there's two different methods of subscription method where you'll create a bucket of link, if you will, which link is the Chainlink token that allows the Oracle nodes to be compensated for the work that they're doing, essentially. One neat thing about it is it's an ERC20 token with the addition of transfer and call, which is essentially, in my mind, I think of it like attaching a sticky note to the payment that you're giving them, saying, hey, here's the work that you need to do with this. So we've got the subscription method, and we have a direct funding method as well. So direct funding is where you could set everything up from a smart contract. It's a little more involved. For the purposes of this, we're going to go through the subscription method. So we want to get a random number. So the first thing that we'll need to do is we will need to open the subscription manager and we'll need to create a subscription. What this is, again, is this is like that bucket of links. So you'll create the subscription and then you can allow other contracts to use this subscription. So you can give it your email address and a project name if you'd like. We'll go ahead and create our subscription now. And we'll wait for confirmation. What's up? We've got some hellos. Hello. How y'all doing? Good to see people using the chat. All right, so we created our subscription. We've got an empty bucket. That's why it has this add funds button. Now, you'll notice I have some link. If I didn't have any link, what would I do? Well, we're on a test net. We could go to the Chainlink faucet. It's at faucets.chain.link. From here, you can prove that you are a human or maybe a very complex large language model who can identify pictures now and get some test link. But I don't need to do that. If you need to do that, feel free to do that. So we'll add some funds. Sure, we'll just pick 5 link. And we'll transfer those funds into our new subscription contract. Once that's completed, we will take a look back at the documentation at what a VRF contract actually looks like in order to get those random values. Okay, so now we have add consumers. So consumers are going to be those contracts that are approved to actually do this. And this is where we're getting kind of this weird state with VRF. So we've got our bucket created, but we need to let the bucket know about the contract. But first, we have to create that contract, right? And one thing to note is you'll need this subscription ID number. So every subscription that you create will have a different ID. So if you're following along, it's going to be different. Mine's 2838. That's kind of fun that they're in order like that. But let's head back to the documentation. So we've done this, we've gone through, we've funded our subscription. Now we need to deploy a VRF compatible contract. So we'll open this in Remix again. And we'll take a look real quick at this contract. I'm realizing, sorry for the last one, may have been too small to read. I always forget when I'm sharing to make my screen bigger. Walk through this contract really quick. So we import several Chainlink contracts here. We've got that coordinator, that's a contract that's going to interact with the Oracle network. We've got our consumer base, that's going to be for this contract. And then we've got confirmed owner, which is allows us to have things like only owner. So import those. Oops, scrolling too fast. We set up some events. We also set up the request status. This is just used for this example, so you can see like whether the request exists, has been fulfilled, what the values are that come back. We have a mapping of the requests. We have our subscription ID, right? Subscription ID. If we go back here and look, that's going to be this value, but we'll set that when we deploy the contract. We have our request IDs and our last request ID. Now, when we were doing data feeds, we had to change some things based on the network, right? And we're going to have to do that here too. So there's a couple different values that we'll need to change. The first is this key hash. This is going to be the gas lane. It specifies the maximum gas price that we can use when we are actually doing things. So if we head to our link that's here, we can take a look at our supported networks, and we'll scroll down to find BNB Chain Testnet. So that was our gas lane. So that's the key hash here that we have. We'll take this value, we'll head back to Remix, pop that value in here. We have a value for our callback gas limit. Now, what this is the way that VRF works is we first ask for random numbers, right? When those random values come back, you remember an important thing to do is to use them right away. Well, when you use them, that can be expensive in terms of gas. So this is setting an upper threshold for how much gas can be used in that callback into your contract. We'll leave it at 100,000 for now because that should be enough for this example. But finding out what that is should be part of when you're deploying a contract like this for actual use. You should figure out what your upper threshold needs to be. If you exceed that, it'll fail the transaction. We have our confirmations. This is how many block confirmations go by before we get our random values back on chain. Depending on the network, it can be lower or higher. I think 3 is normally the minimum threshold for most networks. It can be as high as, I forget how many it is. I want to say 256, but I'm not sure that's right. But the higher the threshold is, the more blocks go by. Essentially, your trade-off here is speed versus security. So the less blocks that go by, the faster you get those random numbers back, the less secure, because you have the ability to be closer to when the block is mined as far as doing anything with those random numbers. The longer you wait, the more secure it is generally. We have our number of words. And I will say, that number of words is a weird term. If you're not familiar with like core, like down in the weeds computer science terminology. So they're random numbers. The technically correct computer science term for those values is words. So they're called words because that's the correct thing to call them. It can be kind of confusing the first time you see words, but in my brain, I've just started translating num words means number of random numbers. So we'll be getting 2 values back. I do know this one's 256. You can get 256 random words back in one request. So that means that with one request out, you can get a bunch of random numbers back if you want them. There's a question here, can you share the code? All of this code is coming directly from our documentation. So if you go to docs.chain.link, it'll be there in all the different sections. We have our constructor here, and this is the other place that we'll need to change something. So you know this is hard-coded for Sepolia. We're not using Sepolia, right? So our coordinator address, that's what we're going to need to change. We head back to our documentation for the test chain. You'll notice here that we have our coordinator address. I will warn you, these are links to the actual coordinator contract, so just be careful when you're highlighting, like start on the edge, copy across, otherwise you'll be sad when your page changes. So we'll grab the address there, we'll pop it in a couple places. Looks like I grabbed a space. So we need to change it here and here. These are both the same address, so we'll change them in both places. This way when the contract is deployed, it will set up the right consumer and coordinator address. We pass in our subscription ID when we actually deploy the contract. And now we get to the function request random words. So this is going to be that request for randomness. We can see here that we use the coordinator that we set up above and we run request random words. We pass in some stuff like the key hash. That's going to be that gas lane that we talked about. Our subscription ID, how many confirmations, what our gas limit is, and how many values we want back. We'll store from that the request ID, and we'll store a couple other things, and we'll emit that event that, hey, the request has been sent. So at this point we said, hey, coordinator, I'd like some random values, please. And the coordinator says, sure thing, on it, it'll take a minute. And then we wait. Once that comes back, well, so we can get our request status as another function here. Once that comes back though, we'll have fulfill random words. So that's gonna be that request coming back into our contract. One thing to note when you're doing this function, request random words, you could name this function whatever you wanted. You could say function, awesome numbers, please. Down here for fulfill random words, you have to name this function fulfill random words. That's what the coordinator is looking for when it makes that call back into your contract. So that's important to remember. So this is where like actually stuff happens, right? So we get those random values back. In this case, all we're doing with them is storing them. But this is where within this function, you'd want to do stuff if you were using those random values, right? This is where you want to assign the rarity of your NFT. You want to pick the background color of your NFT based on those random values. Whatever it is that you're doing with them, this is where you'd want to do it, right? If you're doing the dice rolling, this is where you determine what value that dice comes up as, right here in this function. And again, this is also the function that's going to be interacting with that maximum gas value that you're doing as well, the callback gas limit. You'll need to base that on this function, so the fulfill random words function. All right, so, and then the final thing is that request status that we mentioned just a minute ago. Cool, so we've changed our 2 values here. We should be good to go to deploy. Always remember to change your environment. I can't tell you how many times I forget to change my environment. I'm like, wow, that deployed real fast. And then nothing works. So my subscription ID is 2838. So I'll grab that because when we deploy it, we need to let the contract know about the subscription. We'll click deploy. We'll click confirm. And our contract is deployed here. Now, the next thing we need to do is we need to take the address of this contract and we need to head back to our subscription and let it know about the address, right? So we let our contract know about the subscription. We need to let the subscription know about the contract. Add the consumer, approve the consumer. We'll wait for this. Give it just a moment to see the confirmation. Waiting is the best part of the blockchain. Okay, cool. So this is now our subscription page, and it has things like history, right? We can see that we created a subscription, we funded it, we added a consumer. Again, you can add multiple consumers to the VRF subscription. So at this point, we can head back here and we can say, hey, I'd like to request some random words, please. Confirm this transaction. Got our check mark here. So if we look at the last request ID, we'll see here, we have a request ID. We'll copy that value. We'll say, get the status of that request ID. We can see it hasn't been fulfilled, and we don't have any random words, but hey, it's actually a request, right? If we head back to our subscription page. Oh, it was so fast. So normally this won't be green yet. There'll be like a pending status here while it's waiting to be fulfilled. But you can see here, this is our request. So like we've had the request go through, it's successful. We can see how much link it cost. We can see how much link we have left, all that good stuff, which is pretty cool. If we come back here and we say get request status now, we'll say, hey, it's been fulfilled. And here's our random values. Now, there are two values here. I'll highlight one and leave the other one unhighlighted. They are pretty massive numbers, right? If you want to do something with them using like dice, for example, you could just use the modulo operators, percent sign. It basically says, hey, what's the remainder when I divide it by this number? Another question I get asked a lot is it possible to get the same random number back, like more than once in a row? Technical answer to that question is yes, it's possible. They are truly random numbers. You can see based on the size, they're not small numbers. The odds of you getting the same number are like really tiny, but it is possible. So like if that's something that whatever you're developing can't have happen, you need to make sure and check for that. You could always say, if I've gotten this value before, I increment it by 1 or something like that, if you need to ensure that there is no overlap with random numbers that come back. So that's just something to kind of keep in mind. All right, so that's VRF. We've got our random values back. Moving on to automation. Any questions from y'all about VRF, the verifiable or randomness function? Give it just a moment. All right, we'll move on to automation. And man, look at that guy. He is way beardier than I am now. I like his background, though. It's pretty good. So we have Chainlink Automation. This is going to be using Oracle Network to get our contracts to do stuff. And I mentioned there's two different flavors of Chainlink Automation. There's time-based and custom logic. So let's start off by going through time-based and taking a look at what that looks like. Before we dive into that, though, I'm going to share with you a super complex Solidity contract I made earlier today that we'll be automating. Here it is. I know. I'll give you a minute to like soak in the depth of this contract. It's called basic counter. It has a counter that's public, uint. We set that counter to 0, and then we have this function, count. And it does exactly what you think it would do. It increments counter by 1. So this is like mission critical to my project. I've got this amazing DApp. I call it, make everything count. And this is the linchpin to that entire thing. So we'll deploy this contract real quick and take a look at how it works. Oh, whoa, that was a lot of stuff that went by. May need to refresh this page. Cool, we've got here, I was messing around before. I think we've got basic counter down here at the bottom. That's not it. We're gonna refresh this. Sometimes Remix goes crazy if you haven't talked to it in a while. Okay, come back here, deploy my amazing contract. What's up? Hello, everybody. GM. Cool. So we've got our basic counter. It has two things here. We have counter, which will tell us how many times we count. 0. And we've got count. So we can click this count and we can count, right? Like, cool. Seems to work. We'll wait for our confirmation to come back, make sure it worked. Hey, nice. Number went up. That's what we all want, right? Like number go up. Cool. But like I said, I'm lazy and I'll probably forget to click this button in my mission critical application here. So we should probably do something about that. So let's head back to automation. So we've got time-based automations and we've got custom logic automations. Now, if you just head to automation.chain.link, it should be here, and you can register a new upkeep. Upkeep is what we call automations. So we'll register a new upkeep, and we'll pick time-based automation. Now, we have a target contract address. That's going to be my counter contract in this example. So I'll copy the address, head back here, and paste it on in. It'll complain, hey, I couldn't fetch the ABI. So the ABI, the application binary interface, is essentially a way of letting other programs know how to interact with your contract. If I had taken the time to verify this contract and it was on the Block Explorer as a verified contract, that ABI would have come back and been populated in here. Since I didn't do that, we need to get the ABI. So in Remix, how do we do that? We head back to our compiler tab. All the way down at the bottom is this little tiny button that says ABI. Click that, it'll copy the ABI for us. ABI basically looks like a JSON object. If we make this a little bigger, we can see, it's got all the things like the different inputs and functions that our contract has. So as we paste that in, we click next, and you'll notice, hey, it knows about our function now, count, right? That's the only function we have. If we had more, there'd be more options here for what we want to call. So we'll click next. So we've let automation know about our contract. We've let it know which function we want to be calling. This is where we're setting up when we want that to be called, right? So if you're familiar with crontab, this is just like that from the Unix operating system environments. If you're not, there's kind of an explanation here. There's another website, I believe it's crontab.guru, that will break down the crontab that you created into a human readable format, right? Something like here where it says every 15 minutes, you can create your own and double check it with that website. But I'll run this every 1 minute. What this is, you can see here we have minutes, hours, days of the month, and day of the week. So the way to think about this is we're saying every minute that is evenly divisible by 1. Doesn't be every minute, right? If I said every minute is divisible by 2, that'd be every other minute, only the even minutes, and so on. So we'll say every minute divisible by 1. It'll give you a schedule of the next 5 times that this will run. Cool, looks good to me. We'll say next. We'll name this, make it count. We have my address here. We have our gas limit, again, similar to VRF, right? This is gonna be the maximum value that our function is allowed to use for gas. We'll give it some link. We can provide an email and project name if we like. The email is useful if you have a project that is like seriously mission critical. Put your email in here, you'll get notifications if you like run out of link and stuff like that. We'll register this upkeep. We'll wait for the cron job contract to be deployed, and then we'll request the actual upkeep registration for our contract. Any questions so far? Thoughts, comments, cries of anxiety? So we created the cron job contract. That was the first confirmation. And now we are registering the contract with the counter in it this time. Cool. So now we have our upkeep. It's been registered. Oops. It says that we need more than one link for this, so we'll need to add another link to it. If it is underfunded, it won't run. So what it does is essentially calculates out like a estimated like maximum if you were to use your maximum gas allowance and for the link balance. So if you don't have enough to cover that, it won't run at all. The next thing that we'll take a look at is the custom logic. If you have any questions, seriously, pop them into the chat. But we'll take a look at the custom logic. And then, I don't know, I have a couple projects that I've worked on recently just for demo purposes that I kind of talk through for different ways to use these things. Cool, so we're done there. Refresh this. Should see now that our balance is not 2. Looks like we've already run once. We have, so our upkeep has already been performed, right? So we've got our history here. We funded it twice. We've performed our upkeep. If we head back to Remix and take a look here, hey, look at that. Things are off to the races. Our counter will now count continuously until it runs out of link, basically. So every minute it should count, which is pretty cool. Yeah, you can see it's already run again. If we look at counter now, hey, it's 3, right? So like this is just off running on its own every minute. That's awesome. So let's take a look at this, which is the very basic counter contract, but in terms of what it would look like if we were to use custom logic. So this is directly from our documentation as well. If we were to say custom logic automation, we'd have to open the app again, create a new subscription, or new upkeep, sorry. And down here, it talks about this code example, right? So I've taken this exact contract, I've opened it in Remix, I've gone ahead and done the nice little song and dance of replacing anything that needs to be replaced. I actually don't think there is anything in this one. So I did nothing. So we have our automation here. We'll register a new upkeep. We'll say custom logic. We have our address again. So let's go ahead and deploy this first. Well, looking through this contract, we've got our automation compatible import that we're doing. That's basically to make a contract that is compatible with our custom automation. You'll notice, hey, we've got a counter again. We have interval, which is going to be how often we want this to be updated. In this example, we're going to be recreating the same thing as the basic counter, but using custom logic. So instead of using cron tab, we'll have the check happen inside the smart contract itself. We've got a value last time stamp, so it's going to be the last time something happened. And we have our counter value as well that we're saying 0. When we initialize this, we've got our update interval that we pass in when we deploy our contract, and we set the current block timestamp to be the last timestamp, so it's the last time something happened with our counter. We have 2 functions, and the name of these 2 functions is important. We have check upkeep, and we have perform upkeep. Now, check upkeep, that's going to be, as the name implies, checking if upkeep is needed, right? So you'll notice it returns a Boolean of true or false. It also can return some bytes. So if you need to pass data to your perform upkeep, you can do that. But we are not doing that in this example. So upkeep needed is essentially just, current timestamp minus the last time we did something. Is that greater than our interval? So we'll be using seconds for this. If it is, this will return true, and then it'll come back in and call perform upkeep. And you notice you can pass in those that call data. So it's going to be the same thing that we could have returned from our check upkeep above. So when you are performing upkeep, one thing to keep in mind, best practice, always check and make sure that you actually need to perform your upkeep. A lot of times people ask, hey, how do I make sure that only the Chainlink network calls my automation function, right? Even with the time-based one, how do I make sure someone else doesn't call it, right? If I only want it to happen once a day, how do I make sure that, you can't call my function? And my response to that is this. Why would you not want me to call your function for you? If I were to come to your house and say, hey, I'll pay your utility bill for you, would you be like, oh, no, I always pay my own utility bill? I'd be like, no, heck yeah, pay my utility bill, right? That's essentially what someone's doing. If they try to call your function for you, they're willing to pay the gas fees. Let them do it. But write your functions in such a way that they only execute if they should execute, right? So with this counter, anybody could call it at any time, right? Somebody would be clicking away way more than once a minute. That's cool. Put a check in there. The last time this was called, was it more than a minute ago? If not, don't update the counter. If it was, cool, update that counter, right? Like, think about it that way, where you kind of defensively create your functions. So if someone wants to call it for you, fantastic, let them do it. So we check, should this be run? If it is, we increment our counter. So there's a lot more involved for such a simple example, but let's go ahead and deploy this. Inject the provider, and we'll say our update interval will say 60 seconds again, so every 1 minute. Confirm this, I think we got 10 minutes left. So we are deployed down here. We'll copy this, head to new custom upkeep, we'll paste in here. And notice it can't verify this is automation compatible contract. So it would try to get the ABI and say, hey, does it have check upkeep and perform upkeep? It can't because I didn't verify my contract. Similar problem to the time-based, but it's okay. We know we did the right thing. We can give it a name, the admin address, gas limit, starting balance, say 2. If we want to pass in any data, that's going to be that check data that we were talking about. And project information. We will register this upkeep. And we can view our upkeep now. It's cool. We've got it funded. Wait for it to run. So cool, it just ran, right? Like, go check it out, see what our counter's at. Hey, it's at 1, right? We can say, if we want to check upkeep, does it need to run right now? It doesn't, right? Because it hasn't been a minute since it ran. So that's pretty cool. We could perform upkeep. This is what I was talking about. You can kind of be defensive. We can go ahead and perform our upkeep and see if we can force it to run. And I don't think we should be able to. Yeah, so it just ran and our counter didn't update because we have this if in here, right? So we tried to update it, but we couldn't because we shouldn't be able to update it just yet. At some point in the next minute though, this will update to 2. So this is the basics of what Chainlink offers. I mentioned like some examples I had, and they're not on BNB chain currently, but just some things to look at and check out. So thinking about automation, I made a project that creates this NFT, this Emojigachi NFT. This is actually an NFT. These are the stats from the NFT. When you own this NFT, when you come here, you can actually play with it like a Tamagotchi, if you're familiar with that. Like basically you can feed it and play with it and keep it happy. And the image that's behind the NFT itself would change based on its happiness, right? And how would you go about making sure that like as time passes, you can actually have something happen with your NFT? Automation, right? So like I think I had this set up for every 5 minutes, the hunger and happiness would decrease just a little bit, right? And yeah, it looks like this poor little Emojigachi, he's, you know, not been doing so great because that's a tombstone and it has 33 next to it. So I didn't take very good care of my Emojigachi. Other things is this Flappy Bird clone that I made here. You can play Flappy Bird with an NFT, and you could update like a leaderboard with, you know, current day's winners. You could use automation to refresh that leaderboard every day. So this NFT actually changes the image based on score. It's pretty cool. Pretty fun little demo. But those are just a couple things like using automation that I've done recently using NFTs. I'm a big fan of dynamic NFTs, so NFTs that change based on things that happen. Yeah, I think we've got about 5 minutes left. I don't know if anybody has any questions or not, but that's pretty much it for me. Give you all a minute for any questions, stuff like that. Oh, one other example. I don't know if I have it handy. I had a flower NFT that started off as a seed, and when it would get passed around a certain number of times, it would grow. So like you had to pass it from one wallet to another. And then if it wasn't passed within a certain amount of time based on automation, the flowers would actually die. So you had to continuously pass them around. Otherwise, the NFT would turn into the dead flowers, which is kind of an interesting concept. I don't know. Stuff like that's what I think is kind of fun. Not necessarily useful, but fun. How to get reward. I'm not sure what you mean by that. There's a question here. Chainlink provides access to any kind of oracles. So I'm not sure what you mean by that, by any kind of oracle specifically. So Chainlink provides like the VRF and automation. I think those are pretty straightforward. When it comes to data feeds, those are going to be based on ensuring that the Oracle network has those available to you. So you need to work with different oracles within the Oracle network to get that set up. What is currently in beta, and like I said, it's only on 2 chains currently. It's on Sepolia and Mumbai currently, but plans are to roll it out, is Chainlink Functions, which is really cool. Chainlink Functions allows you to essentially run JavaScript via the Oracle network. So that means that you have access to computation, but also API calls. So as far as any data available, like with that, basically if there's an API, you can reach it, which is really cool. Like those are super exciting, but they're not available on BNB yet. All right, well, guess if there's no other questions, that's it from me. Yeah. Go ahead and stop sharing. I'll hang out in the chat for just a little bit and see if there's any questions that pop up there. But yeah, thanks y'all, and take it easy.